Okay, this video is going to be on the first half of the triangle congruence theorems. We will be adding to our table of contents. So our page 2 table of contents is pretty much full. So you're going to be getting a new one for page 3. So on the very first line, line A, we'll be adding triangle congruence. And if you were in Castor's class, you're putting that on page 48. I'm not sure what page you're on in your other classes. Okay, so the foldable looks like this right here. So this is the outside of the foldable. So it's called triangle congruence theorems, and there's 2 of them listed here. Now there's going to be more of them on the next page. There's going to be 3 more, but you're starting this video with just 2 of them. But I want to start you off by just talking about what it means when 2 shapes are congruent. So if we look at this picture here, this is on the inside of this foldable. So if you open it up, this is the very first picture. It says corresponding parts of congruent triangles are congruent. So all that's saying is if you have 2 congruent triangles, so take a look at these 2 triangles. Now you might want to grab some colored pencils. I'm going to go ahead. Shade each of one of these things. So we have from G to P is 8 long. Now you're going to notice on the other triangle from F to R is 8 long. So these 2 purple pieces are corresponding parts of these 2 congruent triangles. So corresponding just means they match on each of the figures. So you're going to see this 10 side from G to S is going to correspond with this 10 side from K to R. And then we're going to have the third side, I'll do green, it's going to be the PS is 5 long, and it corresponds to or matches the KF on this one. Now, if you have these 3 congruent sides, now remember there's actually 6 parts to a triangle. So we have 6 parts. We have the 3 matching sides, the orange one, the green one, the purple one, but we also have matching angles. So we have this angle. They have put a little double arc right here, is going to match. I can't even see on my picture anymore because I wrote over it. This angle here, because that was a double arc. Then we have, I'll do the red one. This is like a triple arc, matches this one. And then we have one that's the single arc, which is this one, matches this one. So those are all the corresponding matching parts. So notice there are 6 different parts that correspond to each other. So if I tell you 2 triangles are congruent to each other, then that means all 6 parts are congruent to each other. Now, if you had a quadrilateral with like 4 sides, that's going to have 8 corresponding parts because you have 4 sides and 4 angles. So you're going to be able to match them up. And here's the trick. When you name a triangle, they have to say the vertices in the same order for both of them. That way you could tell which pieces match up, which hopefully you learned that from your activity yesterday. Okay, so there is a question on here. What is missing? So if you take a look at this, now clearly there are only 1, 2, 3, 4, 5 parts. So they're asking you, what was the missing one? What piece is missing here? So it looks like they have G matching the R, and they have angle S matching angle K. They have angle P matching angle F. And so it looks like all the angles are taken care of. Now, clearly we're missing one of the sides. So GS, G to S, that was my orange side, right? So my orange side matched my other orange side, K to R. And it doesn't matter if we call it KR or RK, because remember, if it's a segment, you have to name it by its 2 endpoints. So the order does not matter. Then we have GP. G to P, that was my purple one. So G to P, that matched F to R. And they wrote RF, which is this exact same thing. So the side that we're missing is clearly the green side. So what's the green side we're missing? That's the side that's 5 long. So that would be side P to S. Remember, we put the segment bar on top is congruent. Remember, you have the equal sign with the squiggly on top. Sorry, mine's a little bit messy. P to S is matching K to F. My green piece on the other one. So that's how you fill that rest of that top first box in. So after that little first box, you're going to notice that there are 1, 2, 3, 4 more boxes next to this. And this is kind of like just as a reference to go back to. So these are not going to make a whole lot of sense until we do all the theorems. So let's just leave this whole top row alone right now, and we'll be able to revisit it after when we go over the theorems. So we're going to scroll down, or I'm going to scroll down. Make sure you have some colored pencils, because when we have these shapes, it's going to be easier if we have some colored pencils. Okay, so we're going to be doing the SSS, congruent postulate. Okay, SSS, congruent postulate. Let me move this up a little bit. Okay, so what that says is the S's stand for sides. So you might have the side and the side and the side. So that means that if you have 3 sides of one triangle congruent to 3 sides of another triangle, then that means that the triangles are congruent. Now, the reason we have these theorems and postulates is because what we just went through, do you see how there has to be 6 different parts that are congruent in order for these 2 triangles to be congruent? Now, what we don't want to do is have to prove all 6 of them every single time. So these theorems are shortcuts, and they say, hey, guess what? If we just prove these 3 sides, then automatically these angles are also, and I don't have to waste my time proving those also. So that is why we have these theorems. They're just little shortcuts, so you don't have to do all 6 parts, because that's doing too much. So we don't want to do all 6 parts. So if we can get a shortcut, we like that. So here's the first shortcut. The first shortcut is side, 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 congruence postulate. If 3 sides, oopsie, I meant to hit that. If 3 sides of one triangle are congruent to the 3 sides of another, then the triangles are congruent. So if I were able to say, notice in this picture I have 2 triangles here. So this picture down here, side, 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 notice how we have all 3 of these sides match all 3 of these sides. And remember, people are allowed to spin the picture. It doesn't matter if they don't have to be standing up exactly the same way. Congruent means the same length. So it doesn't matter if I were to tip this triangle upside down, for example. We'd still have 3 congruent sides. So these are congruent by side, 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 because we have 1 matching, 2 matching, and 3 matching. So we're going to do a proof now. I know you love those. So we want to prove that triangle ABC, I'm going to paint him yellow, ABC, and you're going to get colored pencils so you can keep track of your triangles. I'm going to look at the yellow guy, is congruent to CDA. So that's my pink guy. So that's what we want to be able to prove. Okay. So now remember, when we set up our proofs, we want to have reasons and statements. So let's set up a little thing. We have our reasons. Oh, I'm sorry, our statements. You know what, I'm going to make this a little bit smaller because I don't think you're going to be able to see. I'm going to actually it's going to be technical difficulties here. My thing won't click. There it goes. Okay, sure, try this again. I'm going to have my yellow triangle, which is this guy, and I'm going to have my pink triangle, which is going to be this guy. Okay, so I'm going to have my reasons, my statements here, statements, and reasons. Okay, so the side, side, side is saying if I were to prove that all 3 pairs of sides are congruent to each other, then I would be able to say that these 2 triangles are congruent. My mouse keeps going crazy on me. Okay, so let's think about step 1. So step 1, you know how we always like to share our givens. So remember, givens are things that they simply say, which they didn't say any words up here. They just told us what to prove. Or they're things that are marked in the picture. So in this, we have some markings. So over here, we see this double line and this double line. I'll make it bigger. And that's saying that those 2 pieces are congruent to each other. So that means that A to B is congruent to D to C. So those two segments are congruent. You might want to do them a certain color. I'll do mine black. That is a statement that is true because it's given. So my reason over here is going to be given. Okay, let's go think about our next thing. Still looking at the picture, it looks like we have a double tick and a double tick. I guess these ones over here were triple ticks, weren't they? So we have this double tick and double tick. These two pink sides from here to here and here to here are marked congruent. So my step 2 would be that from A to D is congruent to B to C. And that is also given because they drew the little ticky marks in the picture. Okay, so this postulate said we had to name all 3 sets of sides. Now, what is the third side of this picture? The third side of this picture, the yellow triangle, do you see how the yellow triangle has this blue side as its third side? And also the pink triangle also has this as a side there. Now, my question is this line the same length as itself? Is A to C on this yellow triangle the same as A to C on this pink triangle? It sure is, because if I were to measure from A to C, it doesn't matter. It's the same length, right? But I still have to state my third statement. So I could say that AC is congruent to AC. And we had a property way in the back of your notebook on the pink paper in my room. I'm not sure what color it was in everyone else's room, but way in the back, we had a statement that said that reflexive property said that something is always congruent to itself. So this is an example of the reflexive property. Reflexive property. And I like to put an X on it because that means that this side is part of this triangle and this side is also a side of this triangle. And I put the X on it because then I remember it's reflexive property. See this little X right here? It helps me remember. And so now when I look at this, I can actually say that these two triangles are congruent because look, if I look at the yellow triangle only, just look at the yellow triangle. Everyone looking at the yellow triangle? The yellow triangle only. If I go around the sides of the yellow triangle, this side, and this side, and this side. Do you notice how I've talked about all 3 of those sides right here? I talked about A to B right there. I talked about B to C right here. And I talked about A to C right here. So do you notice these 3 statements are a side and a side and a side where I talked about it from this yellow triangle only. So what I have here, and I'm going to put these in, let's do it in red. This is a side, right? And this is a side, and this is a side. So by side, 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 all 3 of these sides, and I could check my pink triangle too. If I wanted to check my pink triangle, it's going to be this one and this one and this one, right? Because I matched them, all 3 of them up. So since I have side, 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 I can now say that these 2 triangles are congruent to each other. So I can make my statement number 4. What I wanted to prove was that triangle ABC is congruent to triangle CDA. And my reason is this postulate over here. So number 4, reason is my side, side, side congruence postulate. Good. So I didn't have to worry about proving all 3 angles also. Now, I automatically know that that's going to be true. So since I said these 2 are congruent to each other, the whole triangles, now I automatically know that this angle is congruent to this angle because the corresponding parts of these 2 triangles all have to be congruent now. But I did a shortcut by just doing side, side, side. and then automatically the angles perfectly match out perfect. Okay, make sure you have some color coding and good notes, whatever is going to help you remember. Let's go to the second postulate. Once again, I'm going to make this a little bit smaller so I have some room to write the proof next to it. Okay, here's my second one. The second one is SAS. Now, I want to point something out here. That SAS means that you have, look at this angle. You see where this A is? It's right in between those two sides, in between. And it is touching both sides. So when you write S, A, S, do you see how the S is touching this A and this side is touching that same angle? So when you look at side, angle, side, in order to do it, use it as a shortcut, these two sides have to be coming together right at this angle in our picture. And we're going to show you what that looks like. So it's kind of easy when you think of side, angle, side, SAS, because it's the side that's touching the angle that's touching the next side. So that's how we like to remember how we say it. So we have some things down here. It says if two sides of the included angle. Now included just means in between. So included means it's in between. So two sides and the included, the angle in between them of one triangle are congruent to two sides of the included. So we have two sides and included, congruent to the two sides and included of the other one. And then we would know that those two triangles are congruent to each other. And a picture of it's right here. So if you look at this one single, look at just one triangle. Do you see how the side that they have and the other side that's marked, do you see how they both come in and touch to make this angle? Do you see how they're right in between there? You see how they're coming together to make that angle. So it's the two sides that are wrapping around that angle. That's what we want to try to prove in order to use this postulate. Okay, so let's look at our picture and let's go ahead and start a proof. So we're going to be talking about our, we'll do this blue triangle and this green one. Okay, so I'm talking about a blue triangle and a green triangle. And so the top one is the green one and the bottom one is the blue one. I sometimes like to color code them so I remember which triangle I'm talking about. Okay, so I have my statements and I have my reasons. Okay, so let's look at our picture. What statements do we have? Well, it looks like we do have some markings. Let's do the single tick marks first. So number one, let's do this in pink. Number one, the single tick mark is matching this single tick mark. So that means the segment from A to C, this one, is congruent to the segment that goes from C to E. That's my first statement, and that is a given, right? Next one. It looks like we had a double tick here and a double tick here. So that means that the segment that goes from D to C, so segment D to C, is congruent to the segment that goes from C to B. And that is also given because they drew the little ticky marks in the picture. Remember, they could say it or mark it, and it could be a given. All right, now that's all we're given in this picture, okay? Now, we don't share a common side, but there is something true about these two angles. So let's look at this angle here, this one and this one. Now, remember, what kind of angles are those? Now, remember, they're in the back of your book and your theorems and postulates and all that stuff, the pink sheet in Cass's room. But these two are vertical angles. So remember that vertical angles are congruent to each other. So let's mark those congruent. So how do we name this angle? So we can't say angle C because they would both be angle C, right? And they're two different angles, so we can't call them the same name. So remember, we have to name it like a V shape with the vertex in the middle. So if I want to name this angle right up here, I can go A to C to B. So I can call it angle. Remember, use the angle symbol. A to C to B. Now remember, that's how you trace the picture. So if you're thinking about tracing it, that's from here to here to here. So make sure you name it in that order too. Is congruent to, now I need this angle down at the bottom. How do I name this angle here? Same thing, you gotta name it like a shape, like a V. So I can go from D to C to E. I can go from E to C to D. It doesn't matter. I'm just gonna go from D to C to E. Okay, now what was our reason? Why are those two congruent? It's because of your vertical angle postulate. So vertical angles congruent, or vertical angle postulate, whichever way you like to say it. Both of those would be okay. That says angles, but I was kind of at the edge of the screen. It won't let me write over there. Vertical angles are congruent, or vertical angle postulate. Okay, so we have 3 statements made already. Now I wonder if we have what we wanted, because what had to be true was that our 2 S's have to be coming together to form the A in the middle. Now, when you do this, you want to look at one triangle only. So when you're going to try to name the postulate, look at only one triangle. Okay, put a little star. Look at only one triangle when you try to do this naming the postulate. So I'm going to look only at the blue triangle down here, okay? So I'm legit going to pretend like this top one is scribbled out. Don't scribble that out on your thing, but I can scribble it out on mine. Okay, so I'm only going to look at this triangle, and I'm going to see what is marked. So it looks like I have D to C, right? So I have D to C, D to C, that's right here. That is a side. Then I have C to E. That is another side. And then it looks like I have this angle here, which is this angle right here, right? Now my question is, so I do have, just like we did last time, this is a side, right? This is a side, and this one's an angle. Okay, now we just need to check to see if is the angle where those 2 sides come together. So this side comes up here and that side comes up there, and they do come together to form this angle. So I do have side, angle, side. So I can prove these 2 triangles congruent, which is what they wanted us to do. A, B, C is congruent to triangle E, D, C. And my reason is because of side, angle, side, congruence postulate. Okay, just do make sure that you have the angle where the 2 sides are touching each other. Okay. Okay, this will be going on to page 48. Like I said, we'll talk more about the outside and the very tippy top of this paper after we get them in and start practicing with them.